So we're in your geometry book and we're on chapter 4. And before we do the test, we're going to have to go over chapter 4.7 because some of these questions will be on the test, and then we'll do the test. And there's the next quiz is a little bit, it's actually the most difficult quiz that I thought. But actually when you figure it out, you just have to do a lot of figuring in your mind of how things look in geometry, which some of us are not that great at. It takes a lot of figuring, but you'll be able to do it fine. Theorem 57 says, if two triangles have three angles of one equal respectable to the three angles of another, then the triangles are similar. So basically it's saying if these three angles, and these three angles, then these are similar to those. If three angles are similar or in the midst of it, then you know that those angles, if the angles are all equal, then they are similar, even if they're smaller, okay? That's an easy one. The corollary is to that if two angles of one triangle are equal respectively to two angles of another, the triangles. So basically it's called the angle. So if you have, like two angles, if you have basically, this angle, and then you have another angle similar, then you know that they're going to be, so anytime two angles are equal on two triangles, they're going to be similar. No matter how, if one's bigger than the other, they're going to be similar. So if two right triangles are similar, if they have one acute angle and one that is equal to the acute angle. So basically when you have a right triangle, you're going to have a right triangle means you have one. You basically have one, the right triangle is going to be, of course, this is going to be one of the angles. It's going to be the right triangle. And then if you have another one to another angle, you're going to have those two being similar. So it's really angle, but only one of them is a right triangle or right angle. Theorem 5b says if two triangles have two pairs of sides proportional and included angles equal respectively, then the two triangles are similar. They call that side angle side. So if two pairs, you have two triangles, and they have one angle that's equal, and then two of the other ones are proportional to each other, then that means that they're similar. Basically, like this here would be the case here. So you have one angle, this angle A here, similar. So we only have one angle, but then the two sides, basically this side, BC is similar to this side or proportional to this side, and then if you have another one is proportional, two sides are proportional, and we know that, then you're going to have similar. Two sides are proportional on one angle. We call that side angle with similar triangles. Familiar, isn't it? So on to corollary 58.1 says, if the legs of one triangle are proportional to the legs of another, the triangles are similar. So if you have two legs of a right triangle that are proportional to two legs of the other one, same way. It's the same way, only you're using a right triangle. So if two triangles have their sides respectably proportional, then the triangles are similar. You're called side. If all the sides are similar, to another triangle, then they're proportional. If they're proportional, then they're all similar. Okay? So I hope you got that right. Let's see if I have. I don't think I wrote anything else down there. So okay. Let me see over here what I have before I go on to make sure if I have any. Taking some time here. Okay, basically I wrote the same things. So basically from your book, let's go, we went over what's in your book, and let's go on from there. Sorry I took some extra time here. Let's go on to the next. There was some other thing we need to go over, but we'll just wait. So, so by these theorems, theorem 57 and 59, similar triangles are usually the means of proving that lines are proportional. So if you find that they are similar, you know that their sides are going to be proportional. Select two triangles having two of the given lines and prove that the two triangles are similar. That's what we're going to do. Derive this proportion. It's called, since corresponding sides of similar triangles are proportional, they call it corresponding sides of similar triangles proportional. Then you'll know, and when you do a proof, you can use that CSSTP, saying if you have a similar triangle, corresponding sides are going to be proportional. So just CSSTP. So let's go on here. Oh, before we do this, there's another little tidbit here that you need to know. So to prove that two angles are equal based on similar triangles, use the corresponding angles of similar triangles are equal. So CASTE is another way to express the definition of similar polygons applied to triangles. So basically, this is another way to put the initials there as you go. So corresponding angles of similar triangles are equal. Corresponding angles of similar triangles are equal. So, okay, let's go on up here. 4.9 theorem says, if two parallel are cut by 3 or more transversals passing through a common point, then the corresponding segments of the parallels are proportional. So let's look at this picture. So these parallel lines are cut, and so the corresponding, like this line coming through those parallels, so A and A1 are proportional, B and B1, C and C1, and D. So the corresponding segments. So that means that those segments, corresponding segments, are going to be proportional. AB, they're proving AB right here is to AB, these two, this is AB, and to BC, and to D, CD, right here, CD to CD, these will be proportional. Okay? This last part, proportional segments in right triangles. We're going to have one of these. This is the next quiz is going to be on this. And this is what I had a hard time with too, so hopefully we can get this together here. So let's put it so you can see the whole thing. Okay? It says Theorem 61. In a right triangle, the perpendicular is drawn from the vertex of the right angle to the hypotenuse. The two triangles thus formed are similar to the given triangles and to each other. The perpendicular is the mean proportional between the segments of the hypotenuse. Each leg of the given triangle is the mean proportional between the hypotenuse and the adjacent segment of the hypotenuse. Mean proportional, that's where we have to use that mean proportional. So basically, you're going to have here, you have this right triangle. It's cut by a right perpendicular right here, so that this is going to be, that's going to be a right angle, that's going to be a right angle. This is a right angle. So we have this little triangle here, and this little triangle here, and this big triangle here. They're all going to have 90 degrees, and they're all similar. So you're going to have to figure out which lines are going to be proportional. And it's hard for you to take that out. And if you could cut it out and take it out, then you could figure it out better. But when you're looking at it, you think, oh man, which lines are which? And that's the problem that we're going to have. And I'll show you how to do it. So corollary 61, if a perpendicular is dropped from any point on a circle upon a diameter, we're talking about circles, then the perpendicular is the mean proportional between the segments of the diameter. Mean proportional means it's going to be that center number that you're going to have to square. And so we're going to stop there from your book and start going on to the quiz. So see if this quiz make any sense to you. This quiz is actually going to be harder than the test. So, and I kind of highlighted it. So solve for the required line using the diagram below, show your work. So we know, basically we have a right triangle here. Here's the right number. So you have a right triangle. This is 90 degrees. So here's the big right triangle. We'll just call the biggie. And then we have the second one that's over on this side, that's the second size, and it has a right triangle here. And then you have the smaller one that you're going to have to, basically to be similar, it has to be tipped up on its side. And so this is going to be, so 1, 2, you have this pink one here, the orange one here, and the big green one are all similar. But we have to find out which sides correspond to each other. So let's begin. So this first one, it says if AB equals 8 1/3, so I put down AB equals 8 1/3 here. So see, maybe I did this already. Another sheet of paper so you can see it better because I did a lot of scribbling there. Okay, here I did it here so it's a little better. So basically here, wrote 8 1/3. So we know that this is 8 1/3, right? And so if this is 8 1/3, and BD, let's see here, BD is 3. So if we know that this is 3, we know this is going to be 5 1/3, but right now we're going to put, basically, to find out which ones here, we want to say AB equals 8 1/3. So actually it kind of says here, so AB to BC, AB to BC. BC is this number, and it's the right one, so it's going to be an important one. And then to BC, and then now BC is to BD, this one. So you're good now with this one. You're going to try this little one here and the big one. We're going to forget about this one over here. Forget about the orange, and it's going to be this little pink one compared to this big one. And so I said AB is to BC, right, equals BC to BD. So now we have, see how BC and BC is here? And so this number, as for BC, so BC is here. Now let's see, we don't know what BC is. We're going to find out that it's 5, but we haven't found this number yet. I just wrote it in. So make sure you put all of your letters. So this BC equal BC. So now we're going to say, plug these in. AB is what? AB we found out is 8 1/3. Right there it says AB is 8 1/3. So we put 8 1/3 and equals BC. We don't know what BC is. This is what we're going to find out what BC is. And so we said BC equal BC, because basically BC of this triangle is BC to 3. This is BC to 3, and this is BC to 8 1/3. So 8 1/3 to BC and BC to 3. So now we're going to do our cross multiplying here. So if 8 1/3, 8 1/3 times 3. If we take 8 1/3 times 3, so let's see how we do that. Like this. Look at me here. So we have 8 1/3 over there. To see, we want to do cross multiplying here. So 8 1/3 times 3. So what is 8 1/3 times 3? Or 8 1/3 over 3, I should say. Like that. So you're going to be able, so when you do this, 8 1/3 divided by 3, 8 1/3. So you're going to basically change this into what? 25 thirds. Change 8 1/3 to 25 thirds, which I did right here. 25 thirds and times 3, so we can take that. So it just turns into the number 25. So 8 1/3 times 3 is going to be 25. So 25 equals, and then it's CB times CB is CB square. So CB square equal 25. So what's the square root of 25? The square root of 25 is 5. So our answer is going to be 5. So our answer is 5 there. See how I did that? Basically, the hard part was basically saying 8 1/3 times 3. You got to change this to 25 thirds times 3. So if I did 25 thirds times 3, you can actually get rid of the 3's equal 25. So then we have BC squared equal 25. And it could be, but make sure, see how I put here? Plus and minus 5. Because whenever a square root, you could have negative numbers. So plus and minus 5 is the answer. On to the next one. Similar. Let's show you how I did this. I'm gonna mix this too. Here's my work here too. But let's go here. So this, now we know with the same conditions as number 1, now we want to know what AC is. We want to know what this is here. AC. So we're going to do it again, the same thing. But AB, now we have the same conditions. AC now, of course, look, AC is with the big triangle, you know, AC is with the big triangle. We have AD, we have the numbers of AD. So basically what we're going to do here is what we did up here, only we're going to try to find AC instead of BC. So we have AB over AC, and because AC is going to be our mean triangle. It's going to be this triangle and this big triangle now. So we're going to forget about this little triangle. We're going to do this triangle and the orange and the green. So now we have AB is this big one to AC, and then the common one is AC to, and then AD. Where's AD? AD is right here. That's telling us so. So write this, AB to AC, right here, it's right here. AB to AC equal AC to AD. Okay, now let's put it in. We know that AB is 8 1/3 because it tells us there. We took right here. It says AB is 8 1/3, so we put 8 1/3 divided by AC. We don't know what AC is, and so but we know now AC is actually is of the big triangle this way, and it's also of this triangle. So we have the mean AC over AC, and then we know basically what AD. You know, AD is this number here. We know that if this is 8 1/3 and you subtract 3, this is 5 1/3. So we know that AC, AD is 5 1/3. So you're going to plug in 8 1/3 and 5 1/3. So now 8 1/3. What is 8 1/3? 25 thirds. So you write 25 thirds. What is basically 3 times 5 plus 1 is 16 thirds. So now we have 25 thirds times 16 thirds times AC is AC squared. Okay? So now you have to do 25 times 16. Get your calculator out, or I actually figured it. 25 times 16. So anyway, I don't have it figured here, but found out that 25 times 16, when you calculate out, is 400. So we have 400, and 3 times 3 is 9. So we have 400 over 9 equal AC squared. So now we have to take the square root of 400 over 9 to get that square root of that square. And what do we get? What's the square root of 400? 20 times 20 is 400, so we put 20. And the square root of 9, of course, is 3. So now we can get rid of that square. It's 20 over 3. And what's 20 over 3? 20 over 3, if you divide 3 into 20, you get 6 2/3. So 6 2/3 is going to be AC. That's our answer, 6 2/3. But make sure you put that all there. AB over AC, AC over D, 8 1/3, AC, 5 1/3. And then you are timesing this out, and you're going to get 400 over 9, basically changing this to 25 times 3 and 3, and you get 400 over 9. 409 equals 6 2/3. Plus or minus. I forgot to put the plus or minus there because you're dealing with. So plus or minus there. Okay? So let's go on to number 4. So with the same conditions as number 1, CD. So now we're looking to find out what this number is, CD. So the same conditions we're going to have, we're going to use this as the mean now. So it's going to be, so we have AD is this one. Same conditions of this. So AD to CD. AD to CD. That means this line to this line is going to be proportional to the bigger triangle, which is CD or CD to BD. Actually, now we're comparing this triangle to this triangle, not the bigger one, because we have this line. The CD is going to be two different. It's going to apply to this one and this one. So now we have AD to CD equals CD to BD, and so we know that this one AD is 5 1/3, and we know this little one is 3. So 5 1/3 equal 3, and then we have CD is CD. So now, as I did in this equation right here, 5 1/3 here. So now we have 16. If we take basically 16 thirds and divide it by 3, you'll get 16, right? 16, so you're getting rid of the 3 here. So you have the square root. You have 16 times CD squared, which basically is going to be the square root of 16. What's the square root of 16? It's 4. So basically 4 is going to be your answer. It's going to be 4 because we're looking for CD. So see how I did that? Basically, you did multiply 5 1/3 times 3. You're basically going to take 5 1/3 would be 16 thirds, and then divide it by 3. So it's going to be just 16. So now you have the square root of 16. That's what we have to take. And what is the square root of 16? 4. And it's going to be, again, plus or minus 4, because it could be a minus because it's square root. Whenever you have square root, it could be plus or minus. Okay? Now let's do on to the next two. It gets a little bit more here. So see if I probably do this on here. Might need to look, I kind of drew it on here too now because you're doing a whole new situation. So we have if AD equals 8, CD equals 4, and then BD. So basically you have to draw it. Go ahead and draw it here because this is all messed up. I mean, it's hard to figure that out so many times. So I drew a new one here. A, B, D, but just draw it just like this. And then I put down, we know that AD here is going to be 8. So this is 8, right? And we know that CD is going to be 4. This line's going to be 4. Okay? Hopefully I don't know if you're seeing it on there. There we go. Let's show you. I went off the thing. So here, let's do it over. So I drew a triangle here. Okay? So I have, so this triangle here, I drew here, ACB, just like this, ACB triangle with a line down D. That's all that is to it. So now I fill it in. I have AD equals, here's AD, it equals 8. This equals 8 right here. And CD equals 4. This perpendicular is equal 4. So we know that we got 8 and 4. Then BD is what? So now we have another proportion. So we have a proportion of AD to CD. So basically AD to CD is going to be 8 to 4. So we write 8 to 4 here. And then we have, basically since we have the CDs are mean proportional. It's always, whenever you have a perpendicular, it's going to be that middle number. So CD to CD. And then we're going to compare it to what? BD, because that's the number we want. This number. So it's this triangle here compared to this triangle here, right? And so now we have this. And so now we can say AD is 8 to 4 equal 4. 4 is the middle number to X. So let me show you. Let's do that. Here it is here better. Number 3. So AD, CD, or number 4, I'm sorry. Here we go right here. So we have 8 to CD, CD to 4. So basically doing this, we fill in the blanks here, and you have, as you fill these in, 8 to 4 equal 4 to what? So, which is pretty easy because you know that this reduces to. So basically you're going to do 8x equals 16. So 16 equal 8x. Divide 16 by 8 and you're going to get 2. So BD is going to be 2. And we don't have any plus and minus because CD, we already know what CD is 4. So it's 4 times 4. See, here's 4 times 4. And what we need to find is D in this one, so we don't have to have plus or minus on this one. So basically just fill in AD is 8, right here 8, CD is 4, and then we have 4, because BD, CD, and CD, 4 is the top, and then D is the number we're trying to find. You cross multiply what you get to. Okay, number 5. Similar to this one, we're almost done. So if, okay, I drew another one over here, you know, just to show you. So if BD, here's BD is 4, right? So this number is 4 right here. Can you see it on there? Good, you can. And let me move it over just a little bit more. BD is 4, and then it's compared to BC right here. BC is 6. So we're going to do this small triangle for sure. We're comparing which triangle, this one. So we have 4 and 6 right here. And so then we want to find AD. So now we're going to compare this here. It's this triangle to this triangle, which are congruent. So, and this mean here is going to be the mean, the BC, or actually BC is going to be, so it's because I want to have BC. Okay. AB to BC equal BC. So AB. So what is AB? So AB is going to be AB. We don't know AB. We're going to find AB. So AB is to BC to BC. See how I put this here? So AB is going to be, and then we know BC is 6. This is BC is 6. BC is 6. And then you have 6 to 4. So we do 36 times AB4 right here. 36 times AB4. You're going to find equal 9. Just divide 36 by 4 and you get 9. And so since you have 9 as AB, they want to know what AD is. It's going to be a smaller number. And so what's that number? If you know that this number is 9, here this number is 9, then this number here has to be 9 minus 4 equal 5. So you got that? So this one you didn't have to do either. You just filled in AB to BC, BC to BD, and fill in the numbers. So AB to 6, because BC is 6. BC is 6. BD is 4. And then you just calculate that out. And then make sure you have the right number. Subtract it. AB to make AD. As you subtract it, you will get the number 5. Number 5. Okay, whew, it's done with that one.